Hey everyone, welcome to the next lesson in this unit, which is an introduction to the unit circle. This is going to be quite a heavy lesson. There's going to be a lot of concepts going on, so make sure you guys are just writing down notes and rewinding as you need to in order to make sure you understand all the concepts. So we have 4 objectives this week. The first objective is going to be to be able to construct the 6 trigonometric functions of a point that's on the xy coordinate plane. Then you're going to want to identify the angles on the unit circle in radians and degrees. We're going to want to find the intersection of angles and the unit circle using special right triangles. And then lastly, we're going to want to identify those 6 trig functions for each angle on the unit circle. All right, so let's go ahead and get started. Okay, so we're going to start this lesson with a quick warm-up. These are 2 special right triangles, and we're going to go ahead and solve these. We're going to solve these triangles, which are going to help us later on when we construct the unit circle. So if you notice here, the hypotenuse is 1. That's going to become important when we talk about the unit circle. And we're going to go ahead and solve for the sides, and we're going to use these side lengths later on. So let's see what this looks like. So we know that if I'm trying to solve a 45-45 triangle, I know that, and I'm just going to ignore these right now. We know that these are both going to equal to x, right? And then this side is going to be x radical 2. So now I can go ahead and solve for my equation here, and I can get x all by itself. So we've done this a few times, right? So let's go down here. I've got x radical 2 is equal to 1. We're going to divide each side by radical 2. That way I get x all by itself. Now we can't just multiply or divide by radical 2 because we typically don't want radicals in the denominator. So we're going to have to multiply the top and the bottom by radical 2. That way the denominator cancels out the radicals and I end up with just 2. And then the top is just going to stay as 1 times radical 2. And our x values are now x equals radical 2. So we can go ahead now and erase these. Let's go ahead and erase these variables. And now we're going to replace x with what it equals, right? So x now equals radical 2 over 2. Here x now equals radical 2 over 2. Done. Let's go ahead and look at the next triangle. So we have a 30, 60, 90. So let's go ahead and ignore these sides here. This is going to give me my x opposite the 30. Opposite the 60 is going to give me my x radical 3. And then opposite the 90 degrees is going to give me my 2x. So again, we're just going to take this equation here, and we're going to just go ahead and solve for x here. So this one's going to be a little bit easier. Here we're going to get, I'll put it up here. Here we're going to get x is equal to 1/2. So now I know what x is. Now I can go over here. I can erase my variables. Right now this is going to equal to 1/2. So now it equals to 1/2. And same thing over here. I'm going to erase the y, and now we know it equals 2. And let's go ahead and erase the x, and we're going to replace it with 1/2. Right, but we're not going to leave this as 1/2 radical 3. We're going to rewrite this as y equals radical 3 over 2. All right, so get these side links down in your notes, and we'll come back to them later on in the lesson. Okay, so our first objective here is to be able to find the 6 trig functions when I'm given a point on the xy axis. So we're going to go ahead and start off with our first one here, which is going to be 3, -4. So I'm going to go ahead and plot that point on the x-axis. So let's see, that point, +3. So I'm sorry, not on just the x-axis, but on the xy coordinate plane. So 3, -4. So 1, 2, 3. And then I'm going to go down 4. So 1, 2, 3, 4. So +3 and then down 4. So I'm going to end up somewhere around here. All right, so this is now my point 3, -4. Right, so the important thing about this problem is that when we have a point on the coordinate plane, we're going to create a triangle out of this. So we're going to start with drawing the hypotenuse. The hypotenuse of my triangle is going to start here at the origin at 0, 0, where I started counting, and it's going to end right here at my point. So it's going to start there, it's going to end right at my point. And then I'm going to be able to construct the other two sides using the basically the reference angle, right? So remember what reference angle means. It is the measurement from the x-axis to your angle. So this is my theta right here. That's my angle theta. So now I can create my other two sides, which are going to be the side that goes on the x-axis, and then I have the side that goes on the y-axis. So now we have our right triangle, right? So I can even, let me draw my right angle in here. Try that again. Okay, that's fine. We have a right angle there though, right? We have a right angle right there. Perfect. So now what we want to do is we want to be able to find our 6 trig functions here based off of this right triangle. So we have this side here is 3. We know that this side here is -4. So in order to find our 6 trig functions, we need to know what the hypotenuse is. So quick work, we're just going to do some Pythagorean theorem work off to the side. Let's do it in a different color so we can see it. We're going to have 3 squared plus -4 squared equals my hypotenuse squared. So we know we get 9 plus 16, and I know that this is going to give me 25. So whenever we are looking for the hypotenuse, just know that no matter what the x and y point are, whether they're positive or negative, your hypotenuse should always be positive, right? So let's write a little note here, right? So we're going to want, we know that the hypotenuse, I don't think it's hypotenuse. Yep, hypotenuse is always positive. It's always going to be positive. Okay, so definitely a good note. Definitely a good thing to keep in mind. Let's make that a little bit smaller, right? But there it is. Perfect. Hypotenuse is always going to be positive. So good to know. Okay, let's go ahead and now we can go ahead and complete our 6 trig functions now that we know all the lengths to our sides. So I can go ahead and erase the x, or I can just replace the x with 5. So we know that's 5, and let's go ahead and find our sine, our cosine, and our tangent. So remember, sine is going to be the opposite over the hypotenuse. So the opposite length in this case is my -4. This is my opposite. The 3 is going to be my adjacent. And then my 5 is the hypotenuse, right? Because we're looking from the angle theta. We're looking from this angle right here at theta. All right, so my sine is going to be the opposite side, which is my -4 divided by the hypotenuse. Cosine is going to be the adjacent side divided by the hypotenuse. Let's maybe scroll out a little bit so we can still see the triangle. My tangent is my opposite side divided by my adjacent. Cosecant, we're just going to flip the sign. Secant, we're just going to flip the cosine. And then cotangent, I'm just going to flip the tangent. And there we go. Those are my 6 trig functions. Let's go ahead and look at one more. So -2, -5. So we're going to look at one that is not going to end up with whole numbers. We'll probably end up with a square root in the hypotenuse. So let's see, -2 and -5. So we're going to go left 2. So I'm going to go left 1, 2, and then I'm going to go down 5. So 1, 2, 3, 4, 5. So somewhere around here, right, we've got -2, -5, and now we're going to go ahead and draw our hypotenuse from the center to that point right there. Now, the way we create our triangle is that we are going to need to use the reference angle right here. Right, so that's my angle right there. So now I can go ahead and create my other two sides. So we've got this guy right here, and then I've got my height right there. Perfect. So now I have my right triangle, and let's go ahead and label the sides, right? We know our sides are going to be -2 and then -5, and now we need to find that hypotenuse x. So let's go ahead and find that hypotenuse. We've got -2 squared plus -5 squared is going to equal to x squared. This will give me 4 plus 25, and if we simplify that, we get 29. And let's go ahead and square root each side. So square root, and then we're going to get x equals, x equals the square root of 29. Let's see, does anything break up to 29? I don't think so. I think 29 is prime, so we're just going to leave it as the square root of 29. And let's go ahead and replace it for our x. So x is equal to the square root of 29. And now we can go ahead and complete our sine, cosine. You know what, let me grab this really quick. Let's scoot it over so it's a little bit closer to us. All right, let's put it over here. That way we can see it as we're constructing our sine, cosine, and tangents. All right, so our sine is going to be the opposite side, right? So if this is my angle theta right here, then the opposite has to be the 5, right? That's my opposite side. The hypotenuse is, of course, is going to be the hypotenuse, and then we have the adjacent is the -2. So sine is going to be the opposite side divided by my hypotenuse. We can't have square roots in the denominator, so let's rewrite this. So -5 radical 29 over 29. So guys, I'm not showing the work, so if you have questions on that, let me know. But I'm just rationalizing the denominator by multiplying by radical 29 on the denominator and the numerator. All right, so cosine, we've got -2 over the square root of 29. And again, we need to rationalize this, so I get -2 radical 29 over 29. Tangent is just going to be my opposite side divided by my adjacent side. And then we have the cosecant is going to be just those guys flipped. So when you're creating the cosecant one, take the original one and flip it, right? Because if the radical's in the denominator, when I flip it, now the radical is going to be in the numerator. And then I don't have to worry about rationalizing it. Same thing with the next one. I'm going to take the original cosine and I'm going to flip it. So I get radical 29 over -2. And then on the last one, the cotangent, I'm just going to flip the tangent. So -2 over -5. And there we go. Those are the 6 trig functions when you're finding the length of, when you're given a point on the xy coordinate axis.